Hello, welcome to the machine learning at home. Well, so you did a dimension reduction, and now you have the second matrix. So you had your data with multiple columns, and now after dimension reduction, your data also has multiple columns. But what is good about dimension reduction, you can use like 1, 2 or 3 columns instead of many. Anyway, question: how to understand if the results of dimension reduction are good or bad? So one of the obvious way is to compare it with initial matrix. But how to compare? I will show you two ways. So first of all, we load libraries which we will need for that comparison. I would like to use library vegan and library tapki. So tapki and vegan contain many methods of dimension reduction. So first of all, vegan, and then I use tapki. Library tapki has a bit complicated way of installation, but I hope it is easy enough if you understand your system more or less well. So tapki and vegan, both of them make some dimension reductions. So let me go with dimension reduction first. So one of the most popular one is principal component analysis, and if we take simple iris data, we can make matrix of, for example, 3 columns. For example, iris PCA will be our resulted matrix, and we'll use function prcomp and use iris data as usual without column number 5 -5, and then we will select 3 components, so $x and component from 1 to 3, comma, because we need columns not rows, 1 to 3. So this is our second matrix. So principal component analysis result. First matrix is iris data itself. And we will use another way of dimension reduction. You can use any. I can use, for example, one of methods which is embedded in tapki. So for example, NPE reduction, iris NPE will be the name of our data, and we will use tapki command. In that case it's uppercase, and the same iris data, iris without column number 5, and then we will need to specify some options specific to tapki. For example, we need a method which is NPE, then we'll need a number of dimensions. I will make 3, td equal to 3, and I will also add additional parameters. In that case it will be -key space 50. So that will allow us to calculate results easier. And that's it. So we will use it, and as you see, everything went quite well. So we now have 3 different matrices. First matrix is iris data itself. Second are results of principal component analysis, and third are results of NPE dimension reduction, which we made through tapki, but it can be any way of dimension reduction. And then we will use what? How to understand what is good about your dimension reduction. One of typical solutions is to measure correlation between your initial data and your results of dimension reduction. So for example, we can simply COR, correlation between iris without column number 5 and our iris PCA results of principal component dimension reduction. However, this correlation analysis will give us multiple numbers but we need just to measure how good is our dimension reduction, how to make just one number out of all. One of ways is kind of straw man solution. So we can make apply function, apply, and for that correlation result we apply function which will select the maximal correlation from each row. So function will be function, we apply it for each row, so 1, and then we need a function, anonymous function. I typically will use .x for anonymous function, and function itself will be maximal correlation value. Our correlation values, if you remember, could be negative or positive, so we need absolute value, ABC of .x, and then we need to close our multiple parentheses, so we use apply, and we need 3 parentheses to be closed. And again, that will give us again multiple numbers, like how many rows in that matrix will be our number of numbers, but we will need just one, and this is mean, which will calculate the average of these numbers. So as you see, it's complicatedly looking, but it's actually extremely simple internally. We calculate correlation between our iris data and result of dimension reduction, and then we'll apply function which simply select maximum value from absolute values of correlation, and then we'll calculate average of them. So this is some number which allow us to assess the quality of dimension reduction. So as you see, this is a close to 1, probably is good dimension reduction. So correlation maximal, mean of maximal correlations is about 0.92, very high. And we can use also the same approach for our NPE dimension reduction, NPE. So nothing should be changed except of data name. And well, slightly better. So you see, this is a way how to compare the quality. However, this is a bit strawman approach, as I already said. So we need some more sophisticated solution. And this is why vegan package is for. It contains function which can calculate Mantel test. So Mantel test is a correlation between two matrices. And this is exactly what we want to do. Just one number for two matrices. So we can simply say Mantel, instead of mean, Mantel. And then we can use the distance. So it's a bit complicated again, but you need to know that distance calculate how far away are points from each of numerical set. So we will calculate the distance of iris data, and we will calculate the distance of resulting PCA or NPE. So for example, dist of NPE, and we don't need anything else at the end, and sounds like we have enough parentheses and R will run our function, but let me double check it. It's a common pain with R to calculate how many parentheses you should have. Hopefully I have enough. So let us calculate the Mantel. You see, it's much more output. It will give us the statistic, which is 0.9666, and also, which is very, very good, significance. In the first approach, we didn't have any significance. Here we have significance, so we can calculate, well, how significant is the correlation between two matrices. Very significant. And then we can finally run the same for PCA. So in the first approach, PCA quality was slightly lower. What about the Mantel? Okay, well, almost equal, I would say. so even slightly bigger. So as you see, the differences between these two dimension reductions are not very significant. Our correlation approach give us like slightly more for NPE. Our Mantel approach give us slightly more for PCA. So these two ways are almost equal. But if you use some unusual dimension reduction or in some strange cases, that might be extremely interesting how you can see these numbers different, so maybe very different. So this is a way how to measure the correspondence between your initial matrix and dimension reduction, and also how to calculate which dimension reduction is better. And you can use, as I already call it, like strawman approach, or more sophisticated and also with calculation of significance approach based on Mantel test. Thank you very much.